Hi, welcome everybody. We continue with the lightning talks, and our first speaker is Pavel Šroubl, and he will be talking about how to monitor Prusa 3D printers with Grafana and Prometheus. It's all yours.
Okay, thank you. Good afternoon. I'm here to tell you about how I created a Prometheus exporter for Prusa printers. Yeah. My name is Pavel Šroubl, and I work at Prusa Research as DevOps engineer. My main goal is to make sure that our web services like printables, eShop knowledge base, or others works as they should. And I'm in charge, as you can tell, of observability. Also, I'm in charge of infrastructure, and I try to not destroy our cluster in our cluster. Of course, I work with Grafana and Prometheus, and I make pretty dashboards with cute panels. Instead of that, I enjoy hardware devices. I made like few of them for another company, but let's say it's a long time ago when I made one. I like cars, driving them, going for track days, and also I can make my own beer in the future with monitoring. Okay, what is Prometheus exporter? Prometheus first. Prometheus is a tool for collecting data metrics, and you want to store these data effectively. There is a few ways how to do that. Prometheus is one kind of solution, not only, of course, only one. And exporter is something that provides the data for Prometheus to scrape. It uses pool models, so there is no much overhead for devices, and that was my goal. You can expose metrics on any device, even something like ESP32 or Raspberry Pi Pico, which is not that powerful to handle much more than that it needs. Why? I have multiple printers in my living room. My wife also has a 3D printer, so I wanted to get the data from all of them, from my and hers. So I chose to create a Prometheus exporter for scraping data from these printers. It uses Prusa Link API, so it's public, and you can use it also. And why not visualize these data in Grafana or alert some issues like faulty MMU? Okay. You can also create your own dashboards and probably use even machine learning with technologies like Tamland by GitLab. Okay, how it works? It just works. Somehow, I guess. I used Golang for implementation because it's a common language in Prometheus landscape. It's my first project in Golang, so it looks like that. And I've never been a great programmer, but I can write line or two, maybe three. I used Prometheus library and implemented 3 handlers for different type boards and firmwares that Prusa uses. Unfortunately, right now I support only FDM printers, not the SRE ones. Okay, it's demo time. Okay, this is one dashboard that is used for overview of every printer I have at home. This is body dashboard, which is used for MK4, MK, and Mini. And I have also for Einstein that is used for MK3 and legacy one that will be dropped and deprecated. Okay, sorry, I don't have much time. Okay, current status. Well, it works, but it's a little bit messy, let's say, and I don't have that much time to improve my code, but I would like to improve it. I want to log data from printers to Glocky, get images from cameras to Grafana, and much more. Okay, thanks. I was able to get it in 5 minutes. And if you need anything, you can scan this QR code, which is my repository with this talk. And see you later.
Thank you very much. Our next talk is Jakub Zikl with devs and SREs from frenemies to mates.
All right. Well, this lightning talk serves as a heads up on the significance of not just getting along, but also embracing cooperation and knowledge exchange within our teams. Why? Not so long ago, I witnessed a team of developers who seemed indifferent about their code. They simply pushed their changes to the GitLab and paid no attention to the consequences which occurred. Whether it was on Friday night or Monday morning, the aftermath landed on the shoulders of the SRE or ops team. Well, the ops team had to be on call, tirelessly debugging and hotfixing the bugs which were created by the developers. While this may seem like an easy life for us developers, it doesn't contribute to better collaboration among team members. Why is it important to foster cooperation? Well, when the application doesn't behave as expected, it's easy to engage into the blame game. However, when developers lack understanding of what happens behind the scenes, and the ops team has no insight into how the application actually works, it takes longer to resolve issues and may lead to unfortunate consequences resulting from misinformed choices. How can we address this challenge? If we take a step back, both sides are actually trying to achieve the same goal. While allowing developers to access clusters might seem risky, it's a risk worth taking. By doing so, you reduce the potential damage that developers may cause. As developers understand your craft, they might even bring fresh ideas to the tools you use, and it might shape those tools in the future. By helping developers understand the platform and operations, they, in turn, can help you better understand the application. It becomes a mutually beneficial exchange, leading to improved outcomes. Moreover, this collab journey not only enhances your knowledge, but can also foster meaningful friendships, resulting in even better results. In conclusion, it's crucial to move beyond merely getting along and emphasize the significance of cooperation and knowledge exchange within teams. By breaking down walls between developers and the ops team, we enable a deeper understanding of each other's roles and responsibilities. So, let's embrace this mindset, bridge the gaps, and create a culture of collaboration and shared knowledge. Thank you.
Thank you very much. We have some time. And the next talk will be eBPF verifier, what's Turing completeness by Milan Plžík.
Okay, so hello everyone. We can start a countdown. The clock is not running yet.
That's fine.
Never mind. Okay, good for me. So there was a lot of chat about eBPF during various talks here around. So I thought, since we're on the academic ground here, it might be interesting to have a look at eBPF verifier and what in the world actually the Turing completeness is. Because there was a chat about what everything the eBPF can, because it's running in a kernel, it can hook into various kernel parts of the kernel, and do interesting things with network packets, memory, so on and so forth. So, what in the world, and especially, how does it not break the kernel, since we mere mortals are now essentially running a kernel space code? So, broken kernel code usually means kernel panic, or worse, some kind of security incidents, which we probably don't want to afford that easily. And this usually happens if we load a kernel module that's not exactly okay-ish in the kernel. So possible breakage is usually by reading arbitrary memory, writing arbitrary memory, or getting stuck in an infinite loop. As for what is verifier, so you probably heard that eBPF compiles into bytecode that turns into native instructions inside the kernel. But before the actual compilation into native code, there's a verifier that checks the code by the means of static analysis mostly. So the bytecode is fairly high level and understands type of data stored in variables, and only strict subset of programs is allowed to run. Type checks that are done on the bytecode are basically, so the bytecode understands types. So there are a few basic memory types, for instance, uninitialized memory. So if someone tries to read uninitialized memory, the verifier will figure it out and forbid the program from being loaded. There's a scalar variable, few interesting pointer types that allow us to prevent from accessing memory that shouldn't be accessed otherwise. So by the means of static analysis, there's a pretty good chance that the verifier can figure out what's being broke, that something is being weird and not allow the program to run. Then there's that interesting thing that's called halting problem, that's more from formal languages and automatons, and I'll run through very quickly. So this is basically a problem about deciding whether a program stops or not. So in computability theory, there are a few classes of machines that we can run programs on. It's finite state automata, push-down automata, and Turing machines, and few other exotic ones that we won't get into at all. So what can we say about halting problems on these machines? So firstly, while one is obviously a program that won't halt that easily, all the machines basically speak about what exactly are the instructions that we are allowed to run and what exactly can we do to can the program compute. So deterministic finite state automatons in a nutshell and really quick. So it's fairly simple device that basically has some kind of finite state and it processes some inputs, basically some symbols that are coming to its input. Each step means processing a single input, a single character from an input. And if there's a rule in the program, which is in here, the program will proceed to the next step. If the program processes the whole input, and in some terminal state, then everything is fine and the program has finished. So if we're only allowed to code such a programs, we're fine. We know that these programs finish because at each single step it either processes a letter from an input or halts or basically can't proceed anymore. But these are fairly simple programs that won't allow to do us too much on eBPF. Also, it would do some interesting things. Then there are some more complex ones, as deterministic pushdown automatons. These can also be determined to be stopped, or whether they are terminating or not. And then there's deterministic Turing state machines, which are a complete monster that's actually running. That's actually something that can be simulated on a CPU. Well, it's akin to CPU, and we can't decide where these programs stop. So what about eBPF? eBPF is able to prevent infinite loops in the eBPF programs. Well, kernel eBPF VM is able to prevent these loops because it does static analysis of the whole programs and tries to avoid any kind of situations where there would be an infinite loop. Originally, loops weren't even allowed, and everything had to be unrolled to a sequence of instructions. Now there are some allowed bounded loops. And that's it. For more information, there's the talk. This is something I studied for a few minutes today and thought it would be an interesting thing to share.
Thank you very much. Our next lightning talk is titled Kubernetes at Home, Self-Hosting Lesson. Vadim Rutkovsky.
Yeah.
Oh, can I show this on this one?
Yeah, okay.
Okay.
No, okay.
Perfect. Yeah, we can start, I guess. Hello. My name is Vadim Rutkovsky. I work for Red Hat on day job hacking on OpenShift, and during the rest of the day, I run Kubernetes at home. You may want to ask, why would you want to do the same? Why would you even want to run something at home as an additional machine? The main concern is usually the privacy, because you don't want some of your data to be read by Google or other companies. The examples would be precious moments with your family and photos and things like that. Then you may want to run an entire Nextcloud suite, which allows you to give your own private file storage, calendar, your own local mail, and additional things to integrate with that. And another example might be Linux ISOs in HD quality, totally legal. And anything your heart desires. Some folks run experiments on their cloud. I heard of Kafka streams being run at home. I experiment with Kubernetes just to try out new patches and things like that. An important note why you would not want to self-host. You are now officially becoming an SRE with 24/7 on call, getting messages from your family that something is broken and you need to immediately fix it. So you know that's pretty serious. Why would you want to pick Kubernetes to be running at home? The benefits are that it's declarative, meaning you don't have to work with a bunch of bash scripts and things. You mostly work with YAML, and it's already been stored. If you use GitOps, then you will get much more benefits. Of course, it's much harder to start, but the ease of use outweighs that in the long run. An additional significant benefit is that you get to learn a lot from your live experience. If you're not working with customers directly and so on, you learn what kind of issues you hit when you're running Kubernetes. Few significant tricks to do. I would recommend to use K3s distribution, mostly because it's optimized to be used on slow disks, meaning it doesn't use etcd, which requires a high-speed disk, but it uses SQLite, so you can even run this on slow SSD or even HDD. I would not recommend to use Raspberry Pis as your own single node because they are known to be fairly slow. They are maybe a good fit for your storage nodes to share with NFS and so on, but it's not recommended to run as a production cluster. Ideal nodes for the Kubernetes at home would be Nuke-style devices, the small fanless computers, or the laptops, because they are optimized to be minimal, rather silent, but you must be aware that you have to take out the battery, otherwise it's a fire security hazard. Next lesson is GitOps will save you a lot of time for the maintenance. It's rather hard to describe, but it really showcases how Kubernetes can be descriptive, declarative, and very easy to use. Next, few clouds offer free tiers. Google, Amazon, all of them have them. You may want to use them as their storage. Also, very popular is combining different things, like you don't have to host S3 at home. You can use Amazon's one. It would be much cheaper, and so on. If you may want to expose your server externally, there are a few solutions. One of them is setting up a VPN with WireGuard, but probably the easiest one would be Cloudflare tunnels, which allows you to expose your own internal network to the internet, but you must be aware that it will slow down your home internet, and it's incredibly risky from the security standpoint, so you must understand what you're doing. Few helpful links would be an awesome self-hosted links repository on GitHub. It shows a lot of examples how to run applications, which applications are filling, what are their differences, and so on and so forth. It's a huge list, so you may find something useful for yourself. Next, there is a repository called Kubernetes at Home. It's specifically targeting GitOps plus Helm charts, so it already gives you actual users Helm charts, how they are configuring it, what are the use cases they're filling in, so on and so forth. So it's incredibly helpful to get started. And that's pretty much it.
Perfectly on time. Thank you. Our next talk is, wow, what the heck is Kubernetes multi-tenancy? And our speaker is Dario Tranchitella.
Yeah, but don't worry. I'm used to that faster.
Sorry, can you reintroduce yourself then?
Sorry?
Can you reintroduce yourself so that...
Dario Tranchitella.
Tranchitella.
Yeah, doesn't matter. Dario is enough. Honestly, I hope it works. And I'm going to talk about Dune. No, I'm just joking, but okay. It's mirror, it doesn't work. Oh, it's working, yes. Okay. I can start the timer? Go for it. Yeah. So, hello, everybody. My name is Dario, and I'm going to talk about multi-tenancy. So, what the heck is multi-tenancy? So, essentially, it's an architecture where you're using a shared infrastructure to serve multiple tenants. So the example is obviously the building where you got multiple tenants, so people that is renting several apartments. So why would you like to implement multi-tenancy on Kubernetes? Essentially because you want to optimize the resources and also optimize the cost of your Kubernetes cluster, and also to enhance the governance, because when you're using when you have multiple tenants, so multiple users using your shared infrastructure, you could have issues from the security standpoint. So let's try to understand how can I achieve multi-tenancy on Kubernetes. Essentially, what we have to do is to identify the users. So we need to understand if these users are humans, so people with a token or certificate identifying the users, or rather identifying also service accounts, because if you think about that, the service accounts in Kubernetes, essentially, they are regular users. And then we have to identify the resources in a Kubernetes cluster. So we can think about the Kubernetes resources like storage class, ingress classes, namespaces, pods, and so on and so forth. But we have also some boundaries that are cluster scope. You can think about the nodes or the volumes or the ingress class, the storage class, and also the OS resources like CPU and memory. So keep in mind that right now Kubernetes allows to implement a sort of soft multi-tenancy, and that's the namespace, essentially. Because with the namespace, what we are going to do is to create a sort of slice of your cluster, and in your namespace, you can create your pods, deployments, and all other resources. But unfortunately, it doesn't work from the concept of tenancy, because when you talk about multi-tenancy, especially from the application development, you think about multiple instances. So you don't have a single instance like the namespace. And unfortunately, in Kubernetes, the concept of tenant doesn't exist. But we got all the primitives, so all the resources that we can use to create a multi-tenant environment. And which are these ones? So from the resource control, that is pretty important, because obviously you have to tame the governance of your cluster. You can use the resource quota and the limit range. Resource quota is an API that allows you to set the amount of CPU and memory you can consume in your namespace. And with the limit range, what you're going to do is to set default values and minimum and maximum values for the CPU and memory and so on and so forth. Because obviously, you can run pods without any resource attached to it, and these pods are going to consume all the resources of the node. So you don't want to get that in a shared environment. You have to create boundaries. And then we have to talk about resource isolation. So we can talk about namespaces. Well, everybody knows namespaces, but you have also to isolate the network through network policies and also prevent privilege escalations. So you have to implement the pod security standards or pod security policies, although deprecated. And then obviously you have to implement the RBAC, because otherwise I can start a privilege escalation from the application standpoint. So I can connect to the API server, getting all the nodes, information, sensitive data, and blah, blah, blah. And obviously what you can do is also to isolate the workloads on specific nodes. So you can use a feature introduced by, I don't remember the version of Kubernetes, that allows to place all the workloads of a specific namespace on a set of node pool. So we have all the primitives here, but there is a problem because we don't have the concept of tenant. And that's the reason I would like to present to you a project, my first open source project, honestly, that its name is Capsule. So essentially with Capsule, we introduce a concept, a new CRD that is named tenant, that allows to collect namespaces together. And the architecture is pretty simple because it's an operator, so you can install on any Kubernetes cluster. We are not reinventing the wheel, and essentially we are grouping together namespaces and using a policy engine that is built in Capsule. You can set your own policies, so you can enforce resource quota at the tenant level rather than the namespace level. So how it works. Essentially, we are using all the machinery offered by Kubernetes. So we are identifying the users. So it works with certificates or tokens. And then we are using the webhooks, so the dynamic admission controllers. We are mutating some calls, and we are validating some requests. So can I get all the pods in this namespace? No, you cannot. Or can I create this pod running on untrusted images? Yes, you can, or no, you cannot. And then we are using the owner reference. So the owner reference is the way to create a sort of connection between objects in Kubernetes. Essentially, with the owner reference, you can say this namespace belongs to another resource. So we are able to create a system, a hierarchy between the owner and the child elements, so the tenant and the namespaces. And then finally, we are using the CRDs. So CRDs is a way to extend the Kubernetes API server. We implemented several CRDs, and I think that I'm running out of time. So I try to be as quick as possible, but we are not breaking any user experience, and everything is open source. You can check out on GitHub, and that's all.
Thank you very much. Our next talk seems to be in Czech. It's titled Nepište, scripty, použij, go. And unfortunately, I cannot decipher the name, so I will not even try. So whoever signed up for this talk, please calm down.
Tak jo, ahoj, já vás tu vítám. Já jsem zrecykloval jeden starší talk z jiné konference, ale myslím si, že byl dobrý, protože je to v češtině. Mám všechny slidy v češtině. Já jsem Ondřej Šika, jsem DevOpsák, zabývám se tím, že školím, konzultuju, vlastně motám se kolem DevOps. A v zásadě dneska bych chtěl říkat, proč nechcem psát skripty a tooly v Shellu, ale v Goučku. Tak, proč to vlastně chceme dělat? Tak za prvý chceme si zjednodušit práci. Všichni jsme líní, chceme prostě opakující tásky neřešit pořád poznovu, ale chceme si to nějakým způsobem zjednodušit. Tak, kde to chceme použít? Můžeme generovat kódy, můžeme pracovat s Kubernetem, můžeme mít skripty na testování, v zásadě cokoliv, kde potřebujeme dělat něco opakovaně. Tak, a jo, to řešení, shell skripty, fungují dobře, no, možná ne. A vlastně shell skripty napíšeme jednou, pořád je pouštíme, to je super. Shell máme taky všude, to OK. Jednoduše se píšou, máme nějaký repo s těma shell skriptama, a takže vlastně shell skripty jsou fajn. No, ono to tak úplně není. Všude máme bash, všude máme shell, nebo pokud chceme psát v PostgreSQL shellu, to je hrozný. Máme opravdu všude bash, co když jsme na Windowsech, a najednou jako problém. Opravdu se píšou tak jednoduše, jak jako si myslíme, tak pokud shell script znamená 10 řádků, 10 příkazů pod sebou, tak jo. Pokud tam máme dělat něco složitějšího, jako je práce s nějakýma datama, tak už úplně ne. Distribuce těch shell scriptů, pokud nemůžeme použít Git, typicky nějaký velmi izolovaný prostředí, no nic moc. A to samý bez internetu ještě horší. Tak. A to řešení samozřejmě nějaký je. Můžeme psát ty skripty v Pythonu, ale to nám vlastně přinese jedno zlepšení a zase všechno ostatní bude horší. To zlepšení je v tom, že se to píše líp než ten bash. Můžeme mít hromadu Python knihoven, to je super, ale na druhou stranu Python se možná pouští ještě hůř než ten bash nebo než ten shell, protože ne všude máme Python, ne všude máme Python knihovny, musíme je stahovat, není to úplně nejrychlejší. Distribuce toho je hrozná a potřebujeme na to nějakou závislost, to je ten Python, a potřebujeme mít ty knihovny, což je zase jako další věc. Jak se to distribuuje? No, pořád to není jedna binárka. Tak, takže jedno řešení. Můžeme použít Perl, ale ten je horší jak na psaní, tak na pouštění, a nebo použijeme Goučko. Tak, a proč Goučko? Goučku distribuujeme staticky linkované binárky, což je výhoda, že vlastně nemusíme stahovat nic jiného, kromě naší binárky. Naše binárka v sobě má zakompilováno úplně všechno. Goučko je poměrně jednoduchý jazyk, takže i ty, co v Goučku nevyvíjejí, tak se ho naučí velmi rychle, nebo si osvojí to, co potřebují, velmi rychle. Skvěle se to distribuuje a můžeme to zabalit do brew, že je to jedna binárka, takže je to jako super jednoduchý. A v tom Goučku je na to skvělý tooling. Ať už právě ta distribuce pomocí Go releaseru nebo psaní těch CLI, Cobra Viper nám to velmi, velmi usnadní. Tak. Statické linkované binárky, co to je? Je to binárka, která nemá žádné závislosti. To znamená, je to executable, který pustíte sám o sobě. Potřebujete akorát kernel a tu vaši binárku. Goučku se to spustí nebo zbuildí velmi jednoduše, prostě vypnete CGO a máte to. Takže udělat statickou linkovanou binárku v Goučku super jednoduchý, ve všem ostatním zase tak jednoduchý to není. Potřebujeme teda mít správnou binárku pro každou platformu, ať už je to teda Windows, Linux, Mac, a potom správnou architekturu, čili jestli to je AMDčko nebo ARM. Go releaser nám umožní velmi jednoduše distribuovat ty binárky. V zásadě Go releaser nám zbuildí všechny binárky, všechny optiony, ty buildy nám pušne do GitHubu, takže v GitHubu je máme v releasech, zároveň nám vytvoří bavičky pro brew, bavičky pro scoop, což je Windows Package Manager a celá ta distribuce toho softwaru je potom výrazně jednodušší. Potom samozřejmě distribuce binárek, brew install, na Linuxu bohužel curl a nějaký instalační skript, což je de facto wget a rozbalení. Na Windowsu winget a scoop, takže ta instalace těch našich toolů je potom všude jako jednoduchá. Ještě jsem to nezmínil, Goučko je multiplatformní, to znamená, že to zbuildím jednou a mám to teda, funguje mi to na Windowsech, funguje mi to na Linuxu, na Macu, super. Tak, ty knihovny, které tam použijem, Cobra a Viper. Cobra je knihovna na práci s CVčkem, tu knihovnu využívá například Kubernetes, Argo, v zásadě všechny moderní CVčka, takže Kubernetes klient má tu Cobru taky použitou. Je to super jednoduchý na používání, super příjemný, generuje vám to dokumentaci, generuje vám to helpy, má to autocomplete, všechno je to z krabice, takže nemusíte znovu vymýšlet kolo. Viper je potom na práci s konfigurákama, takže když ty vaše utilitky potřebují někde nějaké konfigurace, uložit si state, uložit si nějaké přihlašování, tak zase můžete velmi jednoduše pracovat s JSONama, s YAMLama, s bizarnostmi jako Toml a načítat věci z environment proměnných. Tak. Funguje tam ten completion by default, to znamená, veškeré vaše tooly budou mít z krabice velmi skvělý autocomplete pro Z-Shell, Bash, ale třeba i pro PowerShell na Windowsech. Vygenerujete z toho dokumentaci, vypadne z toho normálně readmíčko pro GitHub, nebo nejenom readmíčko, ale pro každý příkaz vypadne prostě stránka s nějakým manuálem. Zase to asi místo dostanete v tom CVčku, ale jste to schopni prostě pustit na GitHubu, jste to schopni pustit jako, hodit víceméně všude. Tak a tady vám chci ukázat nějaký moje CVčka, který jsem vytvořil, nebo který pořád jako si tvořím. To první je SLU, což je Cyclops Utils, je to zase nějaké firemní utilitky. Koukám, že už jsem přešel čas, takže se omlouvám. Já to zrychlím, vezmu jenom to SLU, takže tady když tak link, kdybyste se chtěli podívat. A je to právě ta náhrada těch našich shell scriptů. Máme tam věci na práci s Argem, máme tam věci na práci s TLSkem, takže když chci vyparsovat TLSko jednoduše, takhle, SLU se parse, další věci, potřebuji někde generovat logy pro nějaké testování, náhodný generátor logů, potřebuji klíček VPNC, všechno to máme vevnitř. Je to jedna binárka, kterou distribuujeme, žádný skripty, ale jedna věc, zbytek můžu přeskákat, shrnutí. Je to výrazně jednodušší, jak na vývoj, tak na používání, než hromadu shell skriptů. Goučko píše se skvěle, distribuuje se skvěle, je to super. Takže díky za pozornost a jestli jsou nějaké dotazy, tak ptejte se.
Thank you very much. I didn't cut you off because you are the last speaker, so and it was really interesting. So that was.
Okay.